Okay, so you've seen the two main configurations of the operational amplifier, the non-inverting configuration and the inverting configuration. And in fact, almost everything we will do will be one or the other or a combination. As you'll see, we can actually combine the inverting and non-inverting to get something called a difference amp. And that should be on the homework. Let's take a look at the last quiz. It's a pretty simple quiz. We were looking at inverting op-amp configurations. Here's our perfect rules. We want a gain of minus 10, or we could just say a gain of 10 and a phase shift of 180 degrees. I'm going to be lazy and call that minus 10. The output for the signal source is 100 ohms or less. We don't know exactly what it is, so we know that our signal source, let's get that up on the screen, is less than or equal to 100 ohms. We're going to use a inverting configuration, so we know that we're going to use two resistors and a virtual ground. And we get supplies of plus 15 volts, minus 15 volts. And this is an LF411. All right, we know our gain is equal to RF over R1 times V in. We want that to be 10, so we know what the ratio is, but how do we pick those resistors? Well, the first thing is they better be bigger than 1K and less than 1 meg to make me happy. But we also know that the output impedance here is 100 ohms. It has to look into Z in has to be greater than or equal to 10 times 100 ohms, or 1K. Now, we could use a 1K resistor here, but that's going to give us a 10% error. Why would we bother doing that? I certainly wouldn't. I would use if I use a 10K, then I'd have a 1% error. I could use a 100K and get a 0.1% error. Let's go ahead and use 10K. For this to be a gain of 10, RF has to be 10 times bigger. So it has to be 100K. Now, the nice thing about the inverting configuration is it's not 1 plus R1 over R2. So to get a gain of 10 is pretty easy. We just need a 10-to-1 ratio. And of course, 10-to-1 ratios are very easy because our resistors go up in ratios of 10. All right. So we've dealt with this. Our input impedance, Z in, is equal to 10K. So that's fine. We got a gain of 10 because we have 100K over 10K minus is equal to minus 10, and we've got our supplies of plus minus 15 volts. What's the input impedance of your amplifier? Well, the golden rules apply because they tell us that this is at 0 volts because we have negative feedback. V plus and V minus are going to be at the same voltage. This is 0 volts. Looking in here, we see R1 to ground, and that's 10K. So R1 or 10K. What's the output impedance of your amplifier? Well, it is whatever impedance we see from here to ground. And there might be a load resistor. There's certainly 100K to ground or virtual ground here. But none of that matters because internal to the op-amp, we effectively have 0 ohms to ground. It's a voltage source, and the feedback keeps that impedance very low. So the output is approximately 0 ohms. And then you went and did the lab, and hopefully you built this and saw that it worked as it's supposed to.